Well, welcome everyone. Thank you for joining this session on mastering model choice in Amazon Bedrock. We're glad you're here. How many of you are overwhelmed by the number of AI models available when building AI applications? Great. And how many of your organizations have a systematic framework for picking out models for AI applications? All right, fewer hands there. Great. Well, we're here to help. We're going to talk through a simple framework that you and your organization can use to identify models, evaluate those models, and optimize them for production based on the work we're doing with our customers at AWS. I'm Scott Munson, Principal Worldwide AI Specialist with Amazon Bedrock team. Along with me today are John Liu, Principal Product Manager with Amazon Bedrock, and Brian Coe, Senior AI Product Manager with CoinMarketCap. So quick agenda. We're going to start off by just an overview, kind of set the context. What are the challenges that our customers are seeing, and how are we helping them? And then talk through the framework itself. So how do we identify and evaluate and optimize models? And then we'll have a chance to hear from Brian to how he's using this framework and with his team to deploy AI applications that are serving over 65 million monthly active users. So get a sense of the landscape. 2.19 million public models available in Hugging Face today. Chatted with the Chief Product Officer of Hugging Face yesterday. He said there's a new model every 10 seconds. Incredible pace, right? That adds up to about 4,000 models per day. And that's just publicly available open weight models. Add to that all the proprietary model makers, Anthropic, Amazon, OpenAI, all the rest. We have so much choice. This is in every modality. Text, image, video, audio, new modalities. There's so much innovation. It's an exciting time to be building these applications with AI models, but there's a little bit of a bottleneck. I mean, we're hearing from customers that picking the model itself is actually a challenging task. So why is it challenging? What's the consequence of this? What we're hearing is that the POCs matter. When you're building out an AI application for the first time, with your organization, you want to make sure that that's a successful trial run. They're not all guaranteed to be successful, but it matters to our customers that they have a good win early on in this process. And so this matters for the time and labor spent, but also just the momentum and organizational kind of reputational impact. So it can be a tough loss if they pick the wrong model for the job and build around that. We're also hearing this specific problem of no selection framework to work through all the models with, and so we're going to talk through that today, of course. And the pace of innovation is challenging. If it takes 4 weeks to test out your models and pick the one you like, and a better model came out yesterday, it's sort of a challenging environment to work in. So pace is important to our customers. And then, of course, any customer-facing application, any large organization application needs to function at scale. So sometimes our POCs aren't optimized for the big production workloads, and we want to make sure that our customers are successful in that arena as well. So Amazon Bedrock is AWS's solution to provide developers what they need to focus on their developing of applications, and we can kind of provide the rest. Bedrock has a great selection of top models that are kind of coming out continuously, and we're committed to providing great model choices. We optimize our inference to make sure that our customers can use this inference in a serverless manner, so they can scale up and scale down. They can use different modes of inference. They can balance the requirements of their application without having to do all the deployment of AI models themselves. A lot of our customers are seeing success by leveraging their data. So that could be in the form of a RAG knowledge-based solution, or it could be in model distillation or fine-tuning according to their specific proprietary data. And, of course, safety and responsibility are critical. So Amazon Bedrock provides guardrails along with other features that help our customers ship their products with kind of confidence in the reliability and responsibility of their AI applications. And we're doing a lot within agentic work. This week we launched a number of agent core capabilities that are very exciting to help you seamlessly deploy and operate agents at scale. To go a bit further on model options themselves, we really do work with top model providers and continue to expand that number over time. We think that's important. We're hearing from our customers. They want that choice of models, so we're committed to giving them that. Model evaluation tools are a critical kind of counterpart with that to make sure that customers know what the right model is. And we also allow people to import their own models. So if you fine-tune a model or have another model that you're interested in using, we can import that and through custom model import and provide that inference along with the other models available, which is a big kind of convenience factor, again, letting us handle that inference task for customers. And again, Bedrock has, this slide shows 13. We added 4 additional model providers this week. We launched models from Google, from Minimax, from NVIDIA, and from Moonshot. Very exciting. We're over 80 models now available in Amazon Bedrock. We really do hear from our customers and are convinced that us providing this inference for them, this Bedrock service, gives them the simplicity, the scale, and security that they need so they can just focus on their domain and their application development. So, great to have all those models. You still have to pick some to use for your application. And so this is the model selection framework. We've kind of pulled this from working with a lot of customers and trying to simplify it down so you can work with your stakeholders and kind of understand easily what stage you're in. The process itself is relatively simple if you think about it in these terms. First up, you identify candidate models. So you look at all these options and filter them down. We'll go into exactly how to do that in a moment. Then you evaluate those models on your data, on your use case. This is really critical. Generalized benchmarks are not the greatest indicator of what model is going to be most performant to meet your application's requirements. And then we have another step to optimize those models. That might be through breaking up the AI workload into multiple models to meet the performance requirements you need, or potentially through fine-tuning as well. So we'll talk through all of that today. And to help kind of keep us grounded, we're going to use this use case to help understand the process. So we've got a financial crimes investigation agent scenario. This is one that our customers have built, that we've talked, know what this looks like. In this case, financial institution, something gets flagged for potential financial crime. They still are a human review process required. So these analysts are manually reviewing a lot of documents, transaction data. It's time-intensive work, and they want to accelerate this workflow for them. The requirements we're looking at for this application would be to process structured and unstructured data. We want to generate really accurate, concise summaries. This is a large scale, and so we're looking at about 5 billion tokens per day, so we want to make sure we're keeping that in mind as we're picking out the models we want to use. And then, of course, security is essential. The goal here would be to hit 20% efficiency for these humans' workload and be able to work more quickly. So, the identification stage. I'll kind of go into more detail on this. Put simply, we're going to filter out all the models that are relevant by modality and just consider the ones that are relevant for our use case. Next up, we'll look at all those benchmarks. They are valuable. There is utility there, especially the more detailed benchmarks, and then considering benchmarks alongside other metrics that you care about. And finally, we'll look at some differentiated capabilities. There's so much innovation. There's a lot of categories of models, but there's a few that I want to highlight that really we're seeing matter for application success. So first up, modality. This one's relatively simple. What's the input type that the model can ingest, and what's the output type that it provides? Huge amount of text data, of course, in business. A lot of these models were initially started there, so we've got some great options within text. But we're seeing a lot of great use cases develop within image input, video, audio, as well as the outputs of all of those modalities. So step one, just look at the models that are relevant for your use case. And here's a little view on what's available in Bedrock by modality. This can be helpful, right? A lot of great models available within the text category, multimodal input, so those are often text plus image. Also some video understanding available, multimodal output, and then embeddings. A lot of growth in those areas. We're launching new models all the time and meeting more of our customers' needs that way. So we've got it filtered by modality. Now let's think about a way to kind of compare quickly. Artificial analysis is a very popular third-party resource. They provide an index and metrics for a huge range of models as well as inference providers. And it's nice to be able to go here and consider, top intelligence and price or latency or whatever your metric you care most about side by side to kind of quickly evaluate what's the one that I might care about. They also provide this capability to do both X and Y axis, find kind of the sweet spot quadrant where you've got, optimal price to intelligence ratios. In this example, we see a few of our Bedrock models, Claude Haiku, DeepSeek, as well as the GPT OSS models, really standing out in really high intelligence, but really considerably lower prices. So important to take note of that. I think the other thing I want to make sure that we call out is that within benchmarks, often we talk about just a single kind of combined intelligence score, which is really valuable for rapid comparison. But there are really detailed benchmarks, and if you know you have something in your use case that's relevant, for example, long context reasoning, that's something that's really relevant in this use case we're talking about. You can look at specific benchmarks for that. In this case, we've got Claude standing out alongside DeepSeek as some really good contenders for long context reasoning capabilities. This is also an agentic application. So I've highlighted here as well, we've got agentic tool use listed. This is an artificial analysis resource here, but Galileo is another agent leaderboard that's available. There's also Berkeley. Within agentic leaderboards, you've got a lot of variety. How is it as an orchestration or managing level model, and how is it as kind of an executor worker model? How is the tool use selection? There's a lot of meaningful benchmarks that are available when you're trying to pick out the models and which role they should play within an agentic application. So this, again, filters down to kind of consider, hey, what's a couple of top models we should think about? Modalities done, we're thinking about metrics, where does the price performance or other kind of combined ratios, what benchmarks are really strong? I also want to talk about a few other categories of models, and these are ones that I decided to highlight because I see a lot of our customers drive a lot of success with these. There are others, but I really think these are the ones to focus on. First up is reasoning. DeepSeek landed in January. There was reasoning models before then, but a lot of attention, a lot of major model providers adopted reasoning models as part of their even hybrid architecture. So there's a lot available. Reasoning models can do more complex step-by-step roles. Often, again, playing that orchestration role can be valuable in agentic use cases. They can explain the rationale. Very useful when you need to kind of understand why the model made a choice. Traceability is very, very nice to have through that method. Of course, science, math, and coding. Within this category, we have a variety available. The Claude models are good examples. The GPT OSS models. We've got models from DeepSeek, from Qwen, and a number of others that are all reasoning models. Again, agentic, autonomous task completion. Very exciting. I think the best practices are being developed. New offerings are being developed every day. And these are important to consider. What's their tool selection capabilities, orchestration of multiple tools, all the rest there. Customization is worth kind of pausing and considering as well. This tends to be dominated by open weight models. There are some abilities to customize proprietary models. But this is the category where we see the most popularity for open weight models, where the models can be used to fine-tune. And I'll say from our experience, we're seeing customers fine-tune when they have a very specific performance requirement they're having a hard time hitting in any other way. Nothing off the shelf is getting them to the goal they need. And often it's latency sensitive. So if you have a user experience that requires a really quick model response time, often we'll see a customer take a smaller model, distill from a larger, or really have a very specific use case. We're also seeing this grow in agentic applications. So if you've got a worker model that does a very specific task every time, you can fine-tune a model and get really strong results, hitting the latency and cost needs that you might require. So it's worth considering these open weight models, these customizable models, as a candidate in your first identification stage, in case you need to fine-tune or want to have the option to fine-tune later. And we're seeing this also within a specific domain. Terminology may be relevant. And last, this domain specificity. This is something that's important. We're seeing a lot of models develop in this space. I'd say finance, healthcare are two that really stand out. This is driving more success. If you have specific domains where the language is very relevant for that domain, you can sometimes get higher performance, higher intelligence in the model itself. Bedrock Marketplace has a lot of offerings in this area. A couple examples. Upstage is a really good model for Korean language translation. There's also, from Writer, there's a Palmyra financial model as well as a healthcare model. So a few to consider as additional options to, but maybe if your domain has an offering in that space. So back to our use case. Let's look at the financial crimes investigation agent. First step there, filter by modality. These are just text problems that we're solving right now. So text to text, document analysis, summarization. We'd want to look at those benchmarks. We considered summarization specifically, long context reasoning, some of these agentic capabilities well, down to the differentiated capabilities. And then I think it would be, in this case, because it's the financial crimes, there's some terminology, we'd probably want to include a customizable model as well. So that gives us a result, right? We're kind of going from all the models in the world down to a short list that we think would be really strong for this. This would include Claude Sonnet, OpenAI, GPT-OSS in this case, and DeepSeek v3.1. So that's the identify stage. I'm going to now hand off to my colleague John Liu, who's going to talk through evaluation and optimization.
Thank you. All right. So now we get to go into the evaluation stage. And when it comes to evaluation, as Scott mentioned earlier, it's important to have a framework in place to do this. Right? Some of our customers have put in place frameworks that let them evaluate a model and decide whether they want to include that in their production workload within 24 to 48 hours. And today we're going to present a framework that'll help you hopefully set something similar in place. When it comes to evaluation, the first step is always create your golden data set, which is that source of truth that you want to benchmark all your models that you're trying against to see how well it performs. And then when you benchmark these models, you want to make sure you're continuously benchmarking the models, because even if you don't change the model themselves, the incoming context might change, which could lead to unexpected results. So let's go into our sample golden data set and see what that actually is about. The golden data set is really just made up of two pieces. Right? One is going to be the prompt. In this case, it describes out a particular use case we want to measure in our financial crimes agent. And the second part is the source of truth. This is why we call it the golden data set, the ground truth. This is what you want to measure the models that you want to try against and see how close they come to this source of truth. When you create a golden data set, of course, you start with the basics. You want to have a comprehensive data set, about 100 use cases, right, of which you want to choose. They're very specific to your particular terminology, the way that you're thinking of designing your workflow. Because only by creating this tailored data set do you know whether the model that you selected is going to be useful for you. Right? The generic benchmarks that Scott presented first, they're a very good starting point, but you want to see how much of that actually translates to the use case you have in mind. You also don't want to just live in what we call the easy mode. Right? You want to also select cases that are adversarial. Right? You want to trip up the models because you're trying to define where the limits of your model is going to be. And typically, these adversarial use cases, these tricky use cases, they make up about 5% of the 100 use cases that I mentioned earlier. And a good way to start, you set up 10 use cases, and then you get an internal feedback loop with your subject matter experts and build that up to 100. But then as you're rolling out to production, you're introducing more models, you're now thinking about 200, 300 use cases. And potentially there's a better way to scale these golden data sets than continuously lean on human resources, right? Subject matter experts are expensive. So let's take a look if we can do that. What humans are not so great at or not very efficient at doing, is all these detailed tasks, right? These detailed low-level tasks, or trying to create multiple iterations of data sets, or reading detailed SOPs, standard operating procedures, and translating that and making sure that's captured in your golden data set. We can do it, but it's not efficient. And what humans are quite good at doing, a good use of our intuition, right, is the high-level judgment that we have. And we're also quite good at looking at total frameworks and seeing, hey, what works well and what doesn't work well. So you see here, there are 3 things: high-level judgment, setting rules and standards through rubrics, and then looking for ways to improve solutions. So if there's a way that we can leverage the strength of humans and then delegate what we call the low-level tasks to agents, then we've got a pretty good solution to help us scale our golden data set from that 100 to the 200, 300 type of use cases. And now let's look what that actually looks like. We start with the first agent. Right? This is the user simulator. And this, you can think of it, is actually the KYC expert. He's doing the work to find out whether there's a particular financial crime associated or fraudulent detection, fraudulent activity associated with this particular transaction. You have a very descriptive mission for the agent and a persona, and then some example questions. Because the more descriptive you are with your agents, the more accurate they're going to be. You pair this user simulator with your task agent. And this is the agent that actually goes through and does all the work. Looks through all the documents, looks through the online, offline credit cards, for example, synthesizes that information, and comes back with a recommendation to the user saying, hey, is this a fraudulent or not fraudulent activity? Here you can see again, mission, persona described, and they have an action. They have tool calls, right, because they're actually going through and pulling in this information. Finally, you pair this with the critique agent. Right? And this is the actual agent that looks through how close the task agent is, or how well the task agent performs, against a set of rubrics or rules that the subject matter expert, the human, set in place earlier. Here you see the mission, and your job is to go and evaluate the task agent, make sure it does a good job, and your persona, you're an expert teacher. And you've got some tools as well. Your actions are, you have some global evaluation methods, and you have some relative evaluation methods that you call dynamically when you're actually evaluating the task agent itself. Let's put that together. We have our user simulator agent. It passed through a request over to the task agent. Now paired with this, of course, is our critique agent, which is reading rules from this rubric that was defined by the humans. The critique agent continuously iterates what the results are from the task agent until the critique agent says, yes, the response that you gave meets the rubrics that were set in place. And at that point, the critique agent, of course, passes the correct answer back to the task agent, and the task agent now sends it to user simulator, but also the critique agent passes that to the golden data set. So now you're automatically scaling your golden data set. Now where's the human? Right? The human is actually evaluating this entire system at this time. Right? They're not in the detailed weeds of looking at every single one of these responses. They look at how the overall framework behaves. And they can make suggestions that says, how can I improve how the critique agent is actually guiding the task agent? Maybe we need to have more tables that are coming through so it's easier for our customers to read. So they update the rubric, and now this entire golden data set gets stronger, and the rubric gets stronger as well. Now to build this, customers can benefit from AWS's agentic stack. Customers can start with the open source framework, Strands, and very quickly build, deploy locally agents. And as they're ready to scale, they can now lean on Agent Core and benefit from enterprise-grade security and also dedicated runtime environments and memory management. And there were lots of announcements this re:Invent around our Agent Core. So we've gone through, we've created our golden data set. Now we get into the metrics that we want to evaluate against. The operational metrics are the foundational piece: cost, latency, and scalability, just like almost any software, right? Some things to keep in mind, of course, is when you're actually measuring these operational metrics, make sure you're sending in inference requests that cover a variety of patterns, right? You want to look for your P95, your P99 type of response, context window length, so you can find out what the latency is, and you also want to send a variety of different workloads so you can see where the model or the model serving solution you're using runs into errors. Once you have your operational metrics covered, you can move into the comprehensive evaluation metrics around semantics, knowledge, right? So you've probably seen the quality and accuracy, the style and usability, responsible AI. This is pretty much, again, foundational aspects that customers are now used to. However, as customers have been rolling these into production over the last year, they've also introduced their own custom metrics. Because what these custom metrics actually measure, just like any software, there are KPIs that you want to bring in. For example, it could be click-through rates of a particular task you want to get done. Or it could be the type of overrides. Anytime a particular user decides to override what the agent does, maybe that's another KPI you want to bring in. So keep these in mind as you're evaluating your model. Don't just lean on the tried and true quality and accuracy. These are important, but bring in the actual custom metrics from your workload as well. Some other metrics to keep in mind are the temporal consistency. I mentioned a bit earlier, you have to consistently look and evaluate your model. You don't want to make sure you want to detect model drift early on. And as you're introducing more modalities, you want to make sure you're measuring the modality not just in isolation, but also as they interact with each other. And finally, agentic capabilities, right? How well is your entire system or your entire model behaving when it's calling tools or when it's actually orchestrating across different agents? So we've gone through, we've got our metrics. Let's look at what methods are used to evaluate these models. They really break down into three. Right? We start with the benchmarks, the programmatic type of evaluations. And these are really good when it has like a true right or wrong answer. You can think of benchmarks like the MMLU, which measures how good a model behaves for translation, or you could GM8SK, which measures how good a model is for mathematical calculations. Right? Very good starting point. But if you want to pick up the nuances of like summarization or how people talk, how people think, right, then you start leaning on humans. Right? This is where human evaluation comes in. Your subject matters have to come in and look for those nuanced semantic type of evaluation. Now, to help us scale, we can now lean on models as well because they've got much deeper reasoning capabilities that's been developed over the last year. So customers are now using powerful models, whether it's a single powerful model, as a judge to evaluate the output of other models, or they put in place maybe 10 to 12 lightweight models and as a jury evaluate the output of the model that's being evaluated. Amazon Bedrock Model Evaluation supports all three of these. Right? We've got our programmatic evaluation, the human evaluation, and also LLM as a judge. Importantly, we also support custom metrics. And if you want to evaluate models that are not directly within Bedrock, you can do that too. You can bring the responses from those models and run them through Amazon Bedrock Model Evaluation. So let's dive a little bit under LLM as a judge, because that's what we're going to use for our financial crimes agent that we've been using as our reference case. Under the hood, what actually happens is we've optimized the prompts for a variety of our evaluator models, which include the Anthropic models, some of the meta models, and Nova models as well. We tell it how to behave, and we tell it what type of response to give. And what gets passed in is a JSON line file of the golden data set, right? Here's all my prompts, here's my reference answer, and here's also the response from the model that you're going to evaluate against. And to set this up, within Amazon Bedrock Model Evaluation, you start with selecting the models. There are two things you want to select. Right? The model you want to be the evaluator, and the model you want to evaluate. In this case, we're picking the Sonnet 3.7 as the evaluator, and then we're going to evaluate the GPTOS 120B. You select the metrics. Right? Amazon Bedrock Model Evaluation has 12 metrics, and of course, you can also import your custom metrics, as mentioned earlier. And now you run the model evaluation, and you get a result. You can compare different models against each other. In this case, I've run a simple evaluation against the GPT-OSS, as mentioned earlier, and also DeepSeek v3.1, and we can see a radar chart of how well they perform. You can dive deep a little bit as well. Like into each of the prompts that you're evaluating, it gives you a score. Did it from 0 to 1, where 1 being the best score. And if I want to dive in and understand why I got a score as such, I can do that too. I click in and it have an explanation. In this case, it got a 1 because, guess what? The model that you're evaluating matched very well with the ground truth that you actually gave in. Now we can move into the optimized state. And we've gone through, we've evaluated, we have a set of models that we want to choose against. And when we think about optimizing, we want to start by thinking it's not just optimizing a single model. You optimize the entire system. So you can choose single models to replace, and you can also introduce multiple models. Right? You can optimize the entire end-to-end workflow. You can further customize individual models through fine-tuning and distillation, and then you can optimize how you're sending your inference requests for cost and latency. As an example, we announced the inference tiers. And that was in today's Dave Brown keynote, actually. He's talking about the inference tiers around that. And that's where you actually pay a little premium, for example, to access the priority tiers to make sure that your inference are at the top of the line, or you maybe for the less time-sensitive ones, you can pay up to a 50% discount and use the flex tier. Right? This is how you start optimizing cost versus the time of latency. And when it comes to optimizing these multiple models, you have to consider the routing strategies you have. And there are really just 4 things I'd like to share with you today. You can start with rule-based routing. And go through, look at the queries, simple queries, use light model, complex queries, use the heavier models, private queries, for highly sensitive ones, maybe I want to use a model that I'm hosting myself. But that has a challenge too. This means that someone's always writing these rules. So we can benefit from machine learning-based routing. Using classic machine learning, you can train classifiers around the data set that you have, and then route these incoming inference requests to the proper model. Of course, the challenge there is you need a training data set. So you can further benefit from using the LLMs themselves. Right? The LLMs themselves can look at the incoming data and say, well, based on this, we think the profile matches, we should send it to what type of model? Light, medium, heavy. And then you can further fine-tune that as you get more data. Now, best way, of course, combine all 3 of them. Right? That gives you a very robust way to route these inference requests to the different models. When you look at the individual models themselves, you can customize them through a variety of methods through Amazon Bedrock. You can do straight fine-tuning, and you can also do distillation, where you take a teacher model and then bring the knowledge of that into a lighter model. Or you can do some advanced customization on your own through maybe SageMaker and bring those models into Bedrock through Amazon Bedrock's custom model import. And we just announced Nova Forge just about 2 days ago, and that further helps customers customize their models, because now you can not just benefit from your own data set, you can benefit from Nova's pre-trained data set as well. You can bring these 2 data sets together and train the models. So looking at our financial crimes investigation agent after these 2 steps, where are we looking at? Well, we've got the GPT-OSS 120 for fast classification tasks, and then now we've got the Sonnet for the complex analysis. And we fine-tuned the GPT-OSS model, and then we optimized our inference through the different inference tiers that I mentioned, which leads us to an 80% reduction while scaling the workload from 500 million inference requests to 5 billion per day. And we've not talked about the customer behind this, but this is a real customer use case that we've seen in production, benefiting from model choice, the optimizations, the framework that we've talked about so far. Now let's review and just put it all together. In our 3-step framework in action, we start with the identify state. You have a library of models that you want to look at. You review the general benchmarks that are out there, the modalities, and then you select from there the models you want, and you evaluate these models against your specific use case, against the golden data set that you've created. You then optimize the setup that you have, and you can have single model type of workloads, you can have multiple model type of workloads. And importantly, you want to get all this information and bring that feedback so you can improve your particular framework, including monitoring for latency, cost, and accuracy, and also getting the real-time user feedback and having that information improve that golden data set. Another benefit of having a strong golden data set doesn't just power up the model evaluation that you have, you can also use it to fine-tune models. So you get almost like 2 for the price of 1. And that's how this three-step framework works. You put something like this in place, you can be able to evaluate a model for your workload within 24 to 48 hours of it dropping. So with that said, I'd like to bring on Brian, who can show you how CoinMarketCap has done similar type of framework and enabled Gen AI workloads for millions of users daily.
Thanks, John. Hi, everyone. My name is Brian, and I manage AI products in CoinMarketCap. In the next roughly 20 minutes, I'll be walking you through how CoinMarketCap selects models. The analogy I like to use is, although you can use an F1 car to deliver groceries, you wouldn't want to do that. You can use the strongest models, the most advanced models, to do the simplest task. You wouldn't want to do that for different reasons, cost being one of them. Before I continue, how many of you know about CoinMarketCap? Okay, not many people here know about CoinMarketCap, so this slide will be useful. CoinMarketCap is a cryptocurrency data platform, and we've been around since 2013. For reference, one Bitcoin at that time cost roughly $100. When I checked this morning, a Bitcoin was roughly $93,000. More than a decade later, we're at the home of crypto, with over 65 million monthly active users and more than 1 billion page views. If you're more familiar with traditional finance, we're often referred to as the Bloomberg of crypto. We have more than 1 million API users, with institutions like Google, Yahoo Finance, Coinbase, and central banks around the world using our crypto data. Our Gen AI journey started in Q3 2023, and since then, we have more than 10 user-facing products in production. Our AI products are used by millions around the world, and since 2023, we have consumed trillions of LLM tokens, and today, we consume more than 10 billion LLM tokens every single day. This scale is exactly why we are rigorous about our model selection and why Amazon Bedrock matters in our stack. So, what do we use these more than 10 billion tokens for every single day? 4 main things. First, users come to our site to find alphas, to find signals. With more than 27 million cryptocurrencies tracked by CoinMarketCap and thousands more created every single day, there is a lot of noise. LLM compresses this noise into signals, and users use our AI products to find these signals. Second, explain. Users come to our site to try to understand why is Bitcoin price up, why is Bitcoin price down, what is Bitcoin, what is proof of work. And as we all know, AI does a great job explaining all of these. Third, forecasts. Users want price predictions so that they can make money. They want potential scenarios, and although nobody has a crystal ball, AI can help lay out those options and give reasoning behind each of them. Fourth, act. Insight is only useful if you can act on it. We turn AI outputs into watch lists, alerts, and automations so users can act on these insights. Let me show you one of our use cases, what we call CMC AI. This is essentially a chatbot. So imagine you wake up one day, like today, Bitcoin is up, and you wonder why Bitcoin is up. Instead of having to open 10 different tabs, you just go to CMC and ask CMC AI. Using live crypto data, on-chain data, and social sentiment data, it gives you an answer. And then you're wondering, you read about this hack that just happened, and you're wondering, why did it happen? Instead of having to deep dive into many news articles, many social posts, you just ask CMC AI. And of course, this experience is also on our app. Millions of users use CMC's portfolio feature to track their portfolio, and because we have this data, we can personalize the answers for users. The same question by a different user would yield different results, personalized results. Of course, we didn't start from that chatbot that you just saw. Back in 2023, when we started our AI journey, our aim was to minimize risk and maximize learning. We needed two critical components before we scaled to the AI chatbot. First is stakeholder buy-in, and the second is a deep understanding on how to build on top of the non-deterministic nature of LLMs. The image you see on the screen is AI FAQs, one of our earlier products. And when creating this AI FAQs, the reason we chose this is because it's on a less trafficked part of the page, so the risk is lower. And for all the AI FAQs we generate, a human would thoroughly review them to make sure that it is correct, it is accurate before we go live with them. And this manual review process, although tedious and although it took a long time, it was very important because we learned the limitations and strengths of LLMs. With this product, and with more organizational buy-in over time, we built AI products on more prominent parts of our product and more deeply integrated AI within our product. So, as we moved from simple use cases like AI FAQs to what we have now, which is the AI chatbot and many other integrations across the site, one thing we realized is that we cannot have the same model do many different tasks. The example I gave earlier is you don't want to use an F1 car to deliver groceries, and I'll give another analogy. In an F1 pit crew, you have different people for different tasks, and speed and efficiency comes because of that specialization. I'll highlight 5 different tasks that we do within CMC using AI. First is sentiment extractor. Every day, we process millions of social posts, millions of news articles, and we want to extract the sentiment within these social posts and news articles. Is it positive? Is it very positive? Or is it the opposite? The LLM we select here needs to be cheap because I just mentioned the scale. We process millions of social posts and news articles, and it needs to be fast. So the most advanced models typically don't suit this that well. The second is planning. This is about taking the user's query, however complex or ambiguous, and transforming that into a list of to-do lists. This LLM needs to be very good at reasoning, at understanding a user's query, and converting that into a to-do list. The third is data retrieval. This is about taking the data, the to-do list from the second step, and converting that into a list of tool calls. What are tools? Tools are, you can think of tools as API calls that LLMs can make in order to retrieve context. This context can be the latest data, the latest news that the LLM doesn't have access to within its training data. The model that we select here needs to be good at choosing the right tools and the right parameters within those tools. The fourth is summarization. Now that we have retrieved all that data for the large language model, in this step, the LLM needs to take hundreds of pages of data and news articles and convert that into one single page of data for the user to read. And the fifth is translating natural language into CMC IDs. Because we track more than 27 million cryptocurrencies, the same name can represent many different cryptocurrencies. What we found here is that we don't need the strongest model to do this conversion. A simple chat model generally works very good for this. So we care about 3 main things when selecting models for the different use cases I mentioned earlier. One is quality. Quality looks different for each use case. So metrics like factual accuracy, relevance, proper evidence usage, groundedness matter to us, depending on the use case. Second is speed. Time to first token, tokens per second, and time to last token matters a lot to us. And the third is cost efficiency. We don't care very much about the raw cost per token. What we care more about is the cost to quality ratio. So with so many models coming out, I think Scott previously shared that there's one model coming out every 10 seconds. How do we choose which models to test? We can't possibly test every single model every 10 seconds. So in CMC, we have 3 main categories of models. The first, at least the way we think about it, there are 3 main categories of models. The first is full reasoning. These are your top-tier models. They are very good at complex tasks. Using the Claude family of models as examples in this slide, this would be your Sonnet 4.5 and your Opus 4.5. Under the light reasoning models, these are mid-tier models, still with reasoning, and are generally faster and more cost-efficient. This would be your Haiku 4.5. And then the third, fast and low cost. These are lightweight models, typically chat models without any reasoning, that are used for simple and high-volume tasks. This would be your Haiku 3.5. John talked quite a bit about golden data set, and that's what I'm going to be talking about within this slide. So in order to prepare the golden data set, we always start by setting the scope. We need to make clear what is being tested, and over the next couple of slides, we'll use tool calling as an example. If a model has access to 10 tools, we want to make sure that it is calling the right tools to retrieve the right data to generate the answer for the users. Say a user's query only requires 2 of the tools because it doesn't need that much data. The model should not go and fetch data from 5 of the tools and be excessive about tool calling. So that is a scope, tool calling accuracy. The second is ground truth. Humans will prepare the golden data set. Say we have 1,000 user queries that we know users care about. For each of these user query, we will go think about, hey, which tool do you need to call to retrieve the data to answer the question? So say for question 1, we select 4 different tools. That is the ground truth. Third step is we run checks. We call the LLM API, and we give it the 10 tools, and we see what it actually returns to us. Then we compare what they return to us with our ground truth. If the LLM selected 4 tools when our ground truth has 2 tools, then we know something is wrong. There are 3 metrics we care about here: precision, recall, and F1. And I'll talk more about these shortly. And the last is update. This step is super important. Your ground truth will shift over time. Your ground truth needs to reflect what users care about, and what your users care about changes over time. So using the same set of 1,000 questions, maybe 100 of the 1,000 questions will not matter 3 months from now. So you need to remove those 100 questions and change it with something new. Let's dive a bit deeper into tool use. Precision is the first metric we care about. And what it tells us is, amongst the tools that the model actually called, how many of them were correct? How many of them were necessary? Recall tells us, out of all the tools the model should have called, how many did it indeed call? And F1 score combines both of them. So F1 score is essentially a formula between the 2 of them, and it's what we use to compare between models. And the reason why F1 score is important is because, say there are 10 tools, and the model calls all 10 tools. In this case, recall is full, because it called all the tools it needed to call. However, precision is extremely low, and the F1 score will reflect that. So if model A has a F1 score of 0.7, and model B has an F1 score of 0.4, then model A is better, and we will choose that for the tool calling use case. Let's dive into another use case, summarization. Summarization, like I mentioned earlier, is about taking hundreds of pages of content and converting that into a single page, or maybe 2 pages of content for the user to read. The model needs to have very good ability to understand large context, and there are many different metrics we care about here. I'll mention 4. First, is the answer relevant to the user's question? 2, is it readable? 3, is the answer well structured? And 4, groundedness. Is the final answer grounded in the context it was provided? We all know LLMs hallucinate, so what we found is that sometimes LLMs in the final answer will come up with facts that we did not provide it within the context. And groundedness is super important. The chart you see is our test of 7 different LLMs for groundedness. The orange line represents median. The box represents the interquartile range, which means the middle 50% of the results. And the dots represent outliers. You see that the first result has a tight interquartile range and a decent median score. The second result has a very big interquartile range and the highest median result. So it has the potential for the highest result, and it has also potential for low results. And then all the other results just had generally not so good looking metrics. So in this particular test, we selected model 1 because although model 2 had a potential for very good results, it was too unpredictable. So we cannot go with that. Internally, we have this system called GLASS, which stands for Generic LLM as a Judge Evaluation Service. What this does is it allows us to use LLM as judge very easily. It allows any team member to call LLM as judge and to get the results in hours instead of in days. And if anybody wants to use LLM as judge internally, the main thing they have to do is to define the JSON input. They define the goal of the test, they define the dimensions that they care about, and they define the candidates that they are testing. After they have this JSON input, they simply call the API, and underneath the hood of the API, we actually call many different leading models, and all of these models combine together to produce a PDF output that contains charts like what you saw earlier, and also AI insights. Using these AI insights combined with more human evaluation, we can decide which model is good for the job. Model evaluation is not a one-off event. New models come out very frequently, and there are typically two triggers that make us want to do a model evaluation. One is a product insight. Second is a new model coming out that we think is worth testing. The first step of model evaluation is always human evaluation. A lot of models get filtered out simply in this step. So humans, our team, myself or my colleagues, will go in and test the model on a few important use cases. If it passes this stage, we will run the glass system, which is what I mentioned in the previous slide. And then combined with AI insights and more human evaluation, we will know whether this model is suitable for the use case. And if it's suitable, we will push it to production. In production, every single answer is run through an LLM as judge. So we know the quality of all answers generated in production, and we have alerts if something goes wrong. This step is very important because we have gained many insights just from this step. Of course, I need to have a slide talking about how amazing AWS and Amazon Bedrock is. And to be fair, they have been great partners, so I think they fully deserve this. The first is inference. Many models, the latest models, are all available on Amazon Bedrock. Whenever Claude comes out with a new model, Amazon Bedrock has it the same day. To us, calling LLM APIs is just an LLM APIs. We don't deal with infra, we don't deal with scaling, and we're very grateful for that. So that's the main thing that AWS Bedrock helps us with. Amazon Bedrock helps us with. The second thing is RAG. We use Amazon's Open Search service and their Cohere re-ranker. This helps us to fetch the right content for the model to use to answer the user's question. The third is security. Built-in features like zero data retention is super important because we process the portfolio data of millions of users. So we need to have this for our inference provider. And the fourth is hands-on partnership. Since the beginning, Amazon hasn't been just an inference provider. They have always been very helpful, offering deep technical support. And in fact, we are working together on a crypto AI benchmark. And this benchmark will compare general purpose chatbots with CMC AI's ability for crypto use cases. So to sum up, 4 points. First is the use case drives model choice. The best model, a Ferrari car, isn't always suitable for every job, isn't always suitable for delivering groceries. Specialists usually beats generalists for different use cases. The second is that evaluation is not a side project. It is a product. It's never set and forget, and through continuous evaluation, can you convert what may be a fun demo into a production-ready product. The third is humans matter. As much as we try to automate everything away, what we found is that humans alone or humans combined with AI brings us the best insights. And the fourth is the right partner multiplies output. AWS has been super helpful. Amazon Bedrock has been super helpful, and you need to pick the right inference partners. What's next for CMC? There are 3 things that we will be focusing on in 2026. The first is reducing the cost of inference and the speed of inference. And there are a couple of ways we are thinking of doing this. First is through fine-tuning models for different use cases. And the second is model distillation, which is available on Amazon Bedrock. The second is B2B opportunities. So many enterprises have indicated interest in integrating AI within their products. And instead of building it from the ground up, they come to us and ask us for it. So if any of you are in crypto and you want it, reach out to me. And the third is better AI UX and expanded CMC AI capabilities. Users mainly interact with large language models through a chat interface right now. And in order to get the best from that, users need to be expert prompters, and they need to understand the limitations of a chat interface. I don't think that is the future of AI, and I think that AI needs to be more proactive, it needs to be easier to use, it needs to be more personalized, and that's what we'll be focusing on in 2026. So I hope now, 20 minutes later, you are better at choosing models. And if any of you are in crypto, try out CMC AI and let me know what you think. I'll hand the time back to Scott.
Thank you so much, Brian. The work that Brian and his teams are doing is really fantastic. Exciting to see the level of maturity and the scale of production they're working at. Really appreciate you sharing all of that with our audience today. Quick recap. We've got want to kind of reconsider what we talked about today. 3 steps: identifying models, look at the general benchmarks, consider modalities, and pick good candidate models that are relevant for your use case. Next step is evaluate. Run those models in your environment, on your data, on your use case, and generate that golden data set so that you can verify and know that you're picking the right models for your use case, and then optimize those models through model combinations or through fine-tuning to make sure that you're achieving the benchmarks and the performance requirements that you need. And great to hear from CoinMarketCap as well to understand what that looks like in production for them today. I want to close with a few resources that I think would be helpful for you all. The first is an article written by one of our VPs talking about the value of model choice. Nice kind of general purpose explanation of why we're committed to that at Amazon Bedrock. We've also got a model choice page for the Amazon Bedrock website. On that is all those new models we launched, 18 new models in the open weight category, to over 20 this week, and we've also got those new model providers. So lots more coming. Stay tuned, keep watching, more models are on the way. We've also got a few GitHub resources. There's a model evaluation application. This is downloadable. You can run it locally in tandem with Bedrock tools for evaluation. This is one that you can use. Generates a nice visual, just a Streamlit application that you can compare intelligence as well as accuracy, latency, performance, side by side. It's a nice one to kind of share with stakeholders, help them understand why you're picking the model you're picking. And then if you want to go even further, there's a model evaluation workshop available also on GitHub. So take a shot of those. Great resources to get whatever level you want to kind of understand what's available within Amazon Bedrock. I want to thank you all for being here. It was great getting to talk through this with you. There is a little survey, if you don't mind filling that out. That does help us out. We do read those surveys. We're really committed to trying to deliver great presentations for you all. Thank you again for being here today, and enjoy the rest of re:Invent.